In this video, I'll talk about a problem, and I got an email from many of you to make me a video about this problem. So for many of you, this problem were confusing, and I chose to answer by making a video. So what is happening in this problem? You have a capacitor, and this capacitor is charged, and the charge on each plate is Q and minus Q, and the area of each plate is A, and the distance between the plate is D. And remember, this is an isolated capacitor. It is not connected to a battery. And now what we're doing is increasing the distance between the two plates. So now the distance between the two plates is now 2D. If we increase or if we double the distance between the two plates, what happens to the energy stored? That's exactly we're going to calculate. Okay. So remember, the energy stored in a capacitor is given by we denote the energy stored by U, and it is given by half C V squared. And in the problem, we given the Q. We do not know anything about V, so we'll change it to Q. How are we going to do it? We remember the V or Q charge on a capacitor is given by V times C. So from this, what we have is V is equal to Q divided by C. Let's call this as an equation 2, and this is our equation 1. Okay, and we're going to plug 2 in 1. Let's do that. So what will happen is half C, and V squared is now Q squared over C squared, and if you simplify, then U is equal to Q squared over 2C. Let's call this equation 3. And this is a parallel plate capacitor. And for a parallel plate capacitor, the capacitance is given by epsilon naught A over D, and where D is the distance between the plate and A is the area, and epsilon naught, this quantity, is the permittivity of free space. Let's call this equation 4, and I'm going to plug 4 in 3. What do you get? So if I plug this equation 4 into 3, what we'll have is U is equal to Q squared over 2, and C is equal to epsilon naught A over D. And I can simplify it further by Q squared over D over twice epsilon naught A. This is the formula, this is the equation I was looking for, or you were looking for. Okay, so now see, now what happens to the charge? The charge will remain constant even if we move the plates. The charge remains constant, area remains constant, 2 is constant, permittivity of free space is constant. The only parameter changing here is the distance. So what you see here, the energy stored on a capacitor in this particular case is directly proportional to the distance between them. The more we change, the more we increase the distance, the more the energy stored will be. So in this case, if we double If we double the gap, the new energy stored, I'm just calling the new energy stored, will also double. Sorry, the new energy stored will double. Okay, so this is, that means the energy stored will double. Now let's talk about what happens to the potential difference between these two plates. All right, potential difference between these two plates. Okay, so the potential difference between the two plates is given by this equation. V is equal to Q over C. Okay. Now, what is happening to the charge? The charge remains constant. The charge is not changing. The charge remains constant. But what happens to the capacitance? Let's write it down here too. The V is equal to Q, and C, the capacitance value, as you can see from here, is epsilon naught A over D. So I can simplify V as Q over epsilon naught A times D. This is again a very remarkable thing. Q is constant, epsilon naught is constant, A is constant, but D is variable. So if we double the gap, the V, the potential difference between the plates, will also double. So the V, again, I'm going to write down here, if we double the gap, again, if we double the gap, the new potential difference will be again the double. And let me talk again about the electric field. The electric field between the two plates. So there is an electric field between the two plates. What will happen to the electric field? So if you can recall, the electric field value is given by V over D. Okay. So if we increase, and as you have seen here, if we increase D, the V will also increase. So as a result, if I double, now let's say if I double the double, now let's say new, if I make it 2D, what will happen to the potential difference? The potential difference will also double. So it will again be 2V. And as a result, even the electric field will remain unchanged. Okay, let me write down here. If we double the gap, the electric field will remain unchanged. It won't change at all. What is changing here? And again, the Q new won't change. The Q always remain constant. Okay, the electric field will change. The electric field remains constant. The potential difference will double. The capacitance will double. And what happens to the C? The C, as you have seen, the C will remain half. C will go half. So these are the parameters, the changing parameters here. Okay. Now let me show you this one by the simulation. So here I'm using a simulation here. So as you can see, we have the two plates here, and I'm changing. So this is the plate here. This is the plate, and now I'm changing the potential to 1.5 volt. So that means the capacitor is charged now. So, and the charge on the capacitor is given by okay, so this is the charge onto the capacitor, and this is the stored energy. Now let me double the gap, and I'm also going to measure the electric field, the voltage here. First, I will start with the 5 millimeter. Let me see. Or let's say, okay, 3. It's hard to adjust. 3 millimeter or 2 millimeter. I want to make it 5. Okay, 4 is good. So what you have to notice, when the separation between the two is 4 millimeter, the capacitance is 0.44 picofarad, plate charge is 0.66, and this is the stored energy. Now I am disconnecting it from the battery. That means this is an isolated capacitor. And now look at how does the potential and the stored energy changes. If I'm increasing the gap, the stored energy is changing, and so is the voltage. Okay, so that's what exactly I explained in this mathematically. But look at the electric field lines, the black lines here. It's not changing even if I changing the gap. That means the electric field remains constant. The voltage change is changing, the capacitance is changing, but the plate charge, which is by the red colored, is not changing. So the two parameters that remains absolutely constant is the plate charge and the electric field. Thank you so much.